Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. When was the last time someone from your R&D team said, "It can't be done"? Maybe because the part is too big, too stiff, the battery doesn't fit, or the PCB can't bend. Maybe everything fails when humidity is high. For many CEOs, these limits aren't just frustrating, they're a real risk to staying competitive. But what if there's another way? What if you could build a light, flexible, working electronic system, without glass, without hard plastic, and without a traditional PCB? That's exactly what printed electronics makes possible. It's not science fiction, it's a real technology already used in automotive, wearables, and smart packaging, and it's happening in Europe right now. Printed electronics means printing functional layers, conductive, insulating, or sensing inks, onto flexible materials like PET films, TPU, paper, or even fabrics. Instead of designing around a rigid board, you get a thin, lightweight layer that can live inside a shoe, a car seat, a package, or a medical patch. And that changes the rules, especially when your product must be thinner, lighter, cheaper, and smarter at the same time. Let me make this concrete with a real example. Polyend is a Polish company building musical instruments and controllers used by top musicians. In one project, they used printed electronics to create a soft mat with pressure sensors and custom silicone keys, designed and manufactured together with LC Electronic. Traditional PCBs and wiring would have limited the design and user comfort, so instead they printed a flexible sensor layer shaped to fit perfectly. Each mat was customized, both the printed layer and the silicone parts, and the result was a super thin, lightweight interface that responds to pressure and touch with high accuracy. The project required careful tuning, layer thickness, resistance changes, flexible zones, low hysteresis, and the printed approach helped simplify the whole device. No soldering, no bulky parts, and far better use of space. Prototypes were ready just weeks after approval, optimized for small production runs, and produced locally in Poland, which meant fewer surprises and better control over quality. So why do companies choose printing over soldering? First, fewer parts often means cheaper and faster assembly. With printed electronics, you can reduce or eliminate classic PCBs, wires, connectors, extra insulation, and a lot of mechanical complexity. Many functions can be built as one or more printed layers on flexible PET, TPU, or textiles. That simplifies product architecture and removes failure points. It can also shorten the supply chain, because instead of ordering boards, cables, and multiple components from different sources, you can build the function in one place. Some teams even report unit cost reductions of 25 to 30% at volumes around the first 1,000 units. Second, printed components can perform better in demanding conditions. When you remove solder joints and fragile interconnects, you also reduce typical problems like microcracks, corrosion, and contact issues. For sensors, touch controls, and flexible interfaces that need stable performance over time, printed electronics can be a strong engineering choice, not a compromise. Third, removing the hard PCB creates real design freedom. Flexible films and textiles allow electronics to follow curved shapes and live on moving surfaces. Suddenly, electronics can be placed where it used to be impossible. Bent panels, shallow spaces, surfaces that flex, or parts that must remain soft. That opens the door to next-generation products. Smart labels reacting to the environment, car seats with presence sensors, workwear with activity tracking, things that are already being tested and prepared for serial production. Of course, the practical CEO question always comes next. Is it durable? What about water, heat, UV exposure? Can it pass certification? The answer is yes, if you design it properly and validate it properly. At LC Electronic, components are tested under strict conditions, including flexing up to 10,000 cycles, heat up to 85 degrees Celsius, and humidity up to 95%. That's how you turn innovation into something predictable and reliable for industry. Another advantage is speed. A printed electronics prototype can be ready in a few weeks, without molds, without long tooling cycles, and without waiting for shipments from Asia. For many companies, that means time to market can be 30 to 50% shorter, with lower startup costs. But speed is not only an operational benefit, it's strategic freedom. When supply chains are under pressure and uncertainty is the new normal, being able to iterate quickly with a local partner becomes a competitive edge. LC Electronic works in agile sprints, preparing files, testing solutions, building working samples with the customer. So ideas don't get stuck as presentations. They arrive as real prototypes you can hold, test, and improve. This approach also supports fast A/B testing, comparing inks, substrates, touch sensitivity, or button layouts quickly before you lock anything into mass production. And then there's weight. Printed electronics is often dramatically lighter than classic solutions. For simple touch interfaces, weight reductions of 50 to 70% compared to a typical PCB plus wiring and housing are possible. Lighter products are more comfortable to use and easier to transport. That means lower shipping costs, smaller packaging, and less storage space, especially important in automotive, smart metering, outdoor electronics, and wearables, where every gram and centimeter matters. It also supports sustainability goals: less material, fewer hard parts, fewer things to throw away, and a product architecture that can better align with ESG expectations and EU requirements, such as CSRD or EPEAT. So if you're leading a company that wants to build smarter products, struggles with classic PCB constraints, or needs a reliable EU partner for flexible components, printed electronics may be your next strategic move. This is the moment to move on from the old limits of glass, hard plastic, and rigid boards, and start designing electronics that fit your product, not the other way around. Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. This episode of LC Insider was powered by LC Electronic, where printed electronics meet precision engineering. Visit lcelectronic.com to explore materials, cases, and technologies we talked about today.